Okay, in this video we're going to complete the notes for synthetic division. So here it says the remainder theorem, well, the remainder theorem is the following here. If the polynomial f of x is divided by x minus c, then the remainder is f of c. So it's a little bit hard to see this without looking at an example, but it's pretty easy to see with an example. Let's go ahead and do that. So I'm going to refer you back to example 4, where the function was x cubed minus 7x minus 4, and we divided by x plus 2. So this is exactly what we have. The polynomial f of x is divided by x minus c. In this case, this is of the form x minus negative 2, and so our c value is negative 2. So it says now that the remainder would be equal to f of c. So in this case, f of negative 2 would equal to the remainder. So that's what the remainder theorem is saying here. If we divide our function, that's this here, by x plus 2, and in this case our c is negative 2, then f of negative 2 is going to be the remainder that we get when we do that division. So from example 4, we saw that when we divided, we got an answer or quotient of x squared minus 2x minus 3 plus a remainder 2 over the divisor x plus 2. This was our answer, and our remainder was 2, which means for this problem f of negative 2 is equal to 2. That's what the remainder theorem is saying for this case here. So again, this is pretty easy to show with this example. I want to first remind you that we could check our answer. The way that we would check it is we would say x cubed minus 7x minus 4 is equal to our divisor, what we divided by, x plus 2, times the quotient that we got for an answer, plus the remainder, which in this case was 2. This actually gives us an alternative way to write our function. We can write it as x plus 2 times x squared minus 2x minus 3 plus 2. And so now it's very easy to see that f of negative 2 is going to equal our remainder here of 2. Let's plug in negative 2. Again, that's our c value. And notice the minus 2 and the plus 2 here, that's going to give us 0. And 0 times all of this is just going to be 0. We're going to get 0 plus 2, which is 2. And so you can see that f of negative 2 does equal to the remainder. And this is true for any case, not just for this case here. All right, so let's go ahead and use the remainder theorem for examples 1 and 2. It says use synthetic division in the remainder theorem to find the function value. So to find f of negative 2, first of all, in this case, our c is negative 2. And so that means when we divide by x minus our c value, negative 2, or we could write this as x plus 2, when we divide this function by x plus 2, whatever we get for remainder is going to equal f of negative 2. That's what the remainder theorem is saying. So if we're dividing by x plus 2, we're going to put negative 2 in the box. Our coefficients here are 1, negative 6, 11, and negative 6. So let's go ahead and do the synthetic division. If you want to practice, you could always stop the video and go ahead. You should drop the 1 and then multiply. Remember, we do the multiply add here. So we're going to multiply negative 2 times 1, we get negative 2. And now we're going to add this column, and we're going to get negative 8. We always add the columns. So here we have negative 2 times negative 8, so that's 16. When we add, we get 27. When we multiply, we get negative 54. And when we add, we get negative 60. So that means that f of negative 2 is equal to our remainder, negative 60. So now see if you can do example 2. All right, so in example 2, our c value is 3. By the way, remember we use c to represent a 0, and that's really what we have here, 3 Actually, I shouldn't say that because our remainder is not 0 yet, so disregard that. So the remainder theorem says if we divide by x minus c, in this case x minus 3, whatever we get as a remainder will equal h of 3. So this time we're going to put 3 in the box, which is our c value. But we also know when we divide by x minus 3 that we put the 3, a positive 3 in the box. So you can either think of it as the c value, or if you're dividing by x minus 3, you use the opposite sign. So let's go ahead and set this up. Notice that we're missing the x to the 4th term and the x term, and so you're going to need a couple zeros in here. And then you do your synthetic division. So drop the 2. You're going to multiply 2 and 3 to get 6. When you add 0 and 6, you get 6. Multiply the 3 and 6, you get 18. When we add, we get 8. 3 times 8 is 24. When we add here, we get 5. 3 times 5 is 15, and when we add, we get 15. Finally, 3 times 15 is 45, and when we add, we get negative 5, which tells us that h of 3 is equal to negative 5. All right, so I just want to point out one thing here. We know how to find h of 3. We could just plug 3 into the function. Just like on number 1, we could have plugged in negative 2 into the function and we would get negative 60 as well. So you could always do that as a check, but the directions here tell us to use synthetic division in the remainder theorem. So you want to make sure you do it that way, but you can always check it by actually plugging in the value into the function. All right, so let's look at the factor theorem. It says if x minus c is a factor of the polynomial f of x, or that x minus c is a factor of the polynomial f of x, if and only if f of c equals 0. So again, let's look at an example. I'm going to refer you back to example 1 on the first page. We learned that x minus 3 for that problem was a factor of the polynomial f of x equals x squared minus 8x plus 15. So what this is saying is f of c is equal to 0. Well, in our problem, c is 3 here. And so by the remainder theorem, we know that f of 3 is going to equal the remainder. But when we did problem number 1, we got a remainder of 0. And so in this case, f of 3 was equal to 0, which is what the theorem says. Now, it's not really hard to see this. I could show you by writing f of x in factored form. Remember, we divided x squared minus 8x plus 15 by x minus 3, and we got x minus 5. That means that x minus 3 times x minus 5 is equal to our function x squared minus 8x plus 15. So we are saying that f of 3 equals 0. Well, look what happens if you plug in, whoops, I put in the wrong number there. It should be 3. So let me go back and fix this real quick. So f of 3, so we're plugging in 3. Notice 3 minus 3 is 0, so we do multiply. We end up getting 0 times negative 2, which is 0. And so you can see that we do get 0 when we plug in 3 into this function here. So in a statement like this, where it's if and only if, it goes both directions. If f of c is equal to 0, it should be true that x minus c is a factor of f of x. Well, in this case, we have f of 3 equals 0. Well, doesn't that tell us that 3 is a 0 of this function? And we know that if 3 is a 0, that x minus 3 is a factor of this function f. And in fact, that's all we needed to show, and so this does go both directions. All right, let's go ahead and look at a couple of examples where we use the factor theorem. So on number 1, it says, is x minus 2 a factor of x squared minus 5x plus 6? Well, it is if we do synthetic division and we get a remainder of 0. So let's go ahead and do that. In this problem, we're going to put 2 in our box. Again, it's the opposite of the sign here. Or again, you could think of this as x minus c, and it's just our c value. Our coefficients are 1, negative 5, and 6. So let's go ahead and do the synthetic division. When you multiply, you get 2. When we add there, we get negative 3. 2 times negative 3 is negative 6, and when we add, we get 0. So since we got a remainder of 0, the answer here is yes, this is a factor, or x minus 2 is a factor of x squared minus 5x plus 6. By the way, if we wanted to write the other factor, it would just be x minus 3 here. All right, so let's look, you might want to try number 2. Again, if you get a remainder of 0, then you know it's a factor. If you don't get a remainder of 0, then it's not. So here you put negative 5 in the box, and your coefficients, notice you are missing a 0x or an x term, so we got to put a 0x there. So we'll need a placeholder of 0 right there. And so let's go ahead and do the synthetic division. We're going to get negative 5 when we multiply. 2 plus negative 5 is negative 3. When we multiply here, we'll get 15. When you add there, you get 15. 15 times negative 5 is negative 75. And when we add here, we get negative 81. So we certainly didn't get 0. So no, this is not a factor. X plus 5 is not a factor of this polynomial. All right, so now we're ready to use what we've learned. It's the factor theorem that we really care about for what we're going to be doing for the next day or two. So let's look at example 3. This is the type of problem we need to be able to handle. It says factor f completely if x plus 3 is a factor of f of x equals 6x cubed plus 19x squared plus 2x minus 3. Well, if x plus 3 is a factor, then we know when we do the division here, we should get a remainder of 0. So let's go ahead and do that. So we're going to use negative 3 in our little box, and we don't have any zeros to put in here. So there's our coefficients. Go ahead and do the synthetic division. So we'll drop the 6. When we multiply, we get negative 18. When we add, we get 1. 1 times negative 3 is negative 3. When we add here, we get negative 1. Negative 3 times negative 1 is positive 3, and when we add, we get 0. And so you can see that x plus 3 is a factor. We did get a remainder of 0. But the more important thing is we can actually factor this polynomial now. So we divided by x plus 3, and we got this answer here. Now remember, since this is cubed, we're going to drop our degree by 1, so this will be 6x squared plus x minus 1. And so now we've got this factored. But we can go further. Notice this part here can be factored. It looks like, well, I should say it might be able to be factored using the AC method. So let's go ahead and try that. We need two numbers that multiply to negative 6 and add to 1. So 2 and 3 are the numbers that are going to work. You're going to need to make one of those negative. And since we need to add to 1, let's make the negative 2, or the 2 negative. So this is going to work. Notice I can't take a shortcut here because that's a 6. It's not a 1. So I need to split my b term. The plus x there becomes a minus 2x plus 3x. We're just using the numbers we found. And so now we'll factor by grouping. We can factor out a 2x there times 3x minus 1. And when we factor here, we expect to get a 3x minus 1. Notice it's just going to be times 1. So when we factor here using the AC method, we get 3x minus 1 times 2x plus 1. The only thing is, remember we had another factor. It was x plus 3. And so now this is completely factored. There's nothing further that we can factor. And so we're done. Now notice I could have changed this question just a little bit. I could have said, tell me all the zeros of this function. And if that were the case, I would just set each of my factors equal to 0, and I would get the 3 zeros. So that's going to be similar to what we're going to do in the next problem. All right, so it should say example 4 here. So it says solve this equation given that -1 is a 0 of this function. Notice this is just the same as what we had over here. So if -1 is a 0 of this function, then we know x plus 1 is a factor of this function f. And so we know that if we divide by x plus 1, we should get 0 for a remainder. And so when we do the synthetic division, we'll use -1. And there's my coefficients. So let's go ahead and do the synthetic division. Let's see, we're going to get -15. When we multiply and then add, we get -1. Multiply, you get 1. Add, you get -2. Multiply, you get 2. And when we add, we get 0, which is what we were expecting. So we know that f of x can be written as x plus 1 times what we got here. Remember, that's going to have to drop by 1. So since that was cubed, it's going to be 15x squared minus 1x, or just minus x minus 2. So similar to what we did in the last problem, notice this part probably can be factored, or if it can, it would be using the AC method. So we need two numbers that multiply to -30 and add to -1. So 5 and 6 are the numbers that work. You're going to have to make one of them negative. That would be the -6. Notice 5 times -6 is -30, and 5 plus -6 is -1. So let's go ahead and split our b term, and we'll factor out of 5x here. We get 5x times 3x plus 1. So when we factor here, we expect to get a 3x plus 1. So 3x times something is -6x. That's going to be a -2. Notice -2 times 1 does give you the -2 there. And so we end up getting 3x plus 1 times 5x minus 2. And again, the full factorization also includes the x plus 1. So we factored the polynomial. So again, like I said before, you could set each of these equal to 0 and you'd have 3 zeros. But really, we're just solving this equation here. So I'm just going to go ahead and write the factored form over here, although we could just do it where we were on the right, and just set each of these equal to 0, and that'll give you the solutions to this equation. Of course, x is going to be -1. In the middle here, we'll subtract 1 on both sides. We'll get 3x equals -1. Divide by 3, you get x equals -1/3. And on the last one there, you're going to add 2 to both sides. You get 5x equals 2. And divide each side by 5, and you'll get 2/5. And so notice these are the solutions to this equation. They're also the zeros to this function. And remember, they'd also be, that's also what you would use to get the x-intercepts if you were graphing this function. So these types of questions can be asked in a few different ways. You can be asked for factored form, you can be asked for zeros, or in a problem like the one we just did, we're just solving this equation, but we're learning or using what we learned about functions to do it. All right, and that's the end of this equation, or I'm sorry, this video.